liquidations left and right. This is Daniel from Moralis, and today we're going to talk about the very important topic of liquidations to understand how they work under the hood with a little mock platform. This is going to be a code walkthrough. It's not a full project. The video is intended to be a little bit shorter than what we have done before in our full DeFi course. So if you want a more in-depth walkthrough on DeFi, go to that video. In this video, we're going to cover the basics of DeFi borrowing, how over-collateralization works on DeFi, what are liquidations, and we are going to cover that under the hood, looking at the code of a mock DeFi contract. Let's get to the first part. So Aave is one of the platforms of decentralized lending, and in its first version, it worked very similar to this. So let's say that you have 10 ETH and you decide that you want to gain interest on those 10 ETH. And to do that, you deposit those 10 ETH in Aave, in a pool, and then Aave will give you Aave ETH tokens in return that accrue the interest and allow you to withdraw your original ETH. Then, because you have provided some collateral, you are able to borrow up to 80% of the value of your collateral from the same platform in which you staked your collateral. So in this case, we are assuming that the price of ETH is $1,000, and that will imply that you can borrow up to a maximum of 8,000 DAI, because DAI is supposed to be on parity with the US dollar. And this is going to sound a little bit weird to you, right? Why, if you already have 10 ETH that are worth this amount of $1,000 each, which amounts to $10,000, you are borrowing less and leaving this in the lending platform? Well, the reasons might be multiple, but there are two main reasons. One is to kind of play with leverage, which is not advisable, but some people will borrow the DAI and then stake it and then borrow again, and that will allow them to have a leverage position in multiple DeFi platforms or even in the same one. But that's quite risky. Or maybe you just want to keep your DAI on hands. You don't want to sell your ETH, but you need the cash. So you stake your ETH in a DeFi protocol and then you borrow against that. And that's basically the reasons that you will do it. Now, what happens when a liquidation occurs? Well, a liquidation occurs when the value of your collateral changes. So all DeFi platforms that are well run will rely on an independent oracle service such as Chainlink to report what is the current price of the collaterals. You are depending on this formula to calculate what is called the health factor. And the health factor is nothing more than the value of your collateral divided by your borrowed asset value. Of course, if these two are equal, then it's a little bit risky for the platform. So usually you over-collateralized. And you do that by multiplying the collateral value by the liquidation threshold that you have established. The value of your borrow amounts can never exceed your collateral value already adjusted for the liquidation threshold. If these two are the same, that means if you have borrowed the maximum amount that you can borrow, which is 80% of your collateral, then this division will be 1. But if your collateral value decreases, and that could happen because the price of the assets that you hold as collateral has changed, then you will be open for liquidations. And the liquidation is no more than a third party paying your debt for you, but taking a commission for that and appropriating a part of your collateral. That liquidation could also happen because the value of your borrowed assets has changed, and that could happen because the accruing of interest. Each block that is added to the blockchain, there are yields that are paid by the platform to liquidity providers, but those yields are paid from the borrowers. So if you have borrowed too much, you might fall into a health factor of less than 1 just by the growing of your borrow value, even if your collateral value remained the same. We are going to check now how that works under the hood in our mock contract. We are going to work with this lending contract that is in the GitHub repository that is in the description of the video. That GitHub repository has 2 folders. One is front end and the other one is Solidity. In the Solidity folder, we have 4 files. The main one is this lending platform that we are going to analyze right now. We have a mock oracle because remember, each lending platform relies on an oracle service, and also a token contract because when we do a little demo, we will need some tokens to work with our lending platform. Also, we have this interface that allows us to work with our oracle through the lending platform. So we start by here. We have this contract that of course is not audited, so not meant to use in production. And we are going to go line by line through it, but we're going to focus in the liquidation part. So we have several files that were important. We have a reentrancy guard, which is to secure against reentrancy, our most important functions. This is ownable because this contract is supposed to have some functions that are controlled by the platform, like whitelisting what tokens are allowed to become collateral in this lending platform, our interface that we just mentioned, and then our interface to communicate with the ERC20 tokens that are the tokens that are going to be working with the platform. We have certain errors here, which are very similar to events. As we have it here, the contract is ownable because we are supposed to have certain functions that are only triggered by the owner of the platform. Then we have a series of state variables. What we are managing here is basically allowing us to map what tokens are allowed in our platform, and then we map the address of those tokens through this mapping to their specific price feed, or the mock oracle that will contain the price of that specific token in this case. So these are these two. The array is the allowed tokens, and this is to map each token to its specific price feed. Then the other 2 mappings are to map the deposits of each of the tokens to their owner and ultimately to their balance. So each address of the user of our platform could be mapped to a lot of different token addresses, and each of those token addresses will have a certain balance, in this case for deposits and in this case for borrows. That part is quite simple. Then we have certain constants that are going to be used in the lifetime of our protocol. We have a liquidation reward. This is going to be paid to liquidators when they perform a liquidation. We have our liquidation threshold that is set to 80% here, and the minimum health factor, which is going to be 1. We are adding 8 decimals to this one because we are going to be working with USD and Chainlink, which is kind of like the standard that we are going to try to follow for getting the values in USDs. Also give USD 8 decimals, and since the value of the collateral divided by the value of the borrow amounts is what will give us the health factor, then this health factor should have the same number of decimals than those 2 figures. These events are just triggered under specific circumstances. So we have the events that can happen in our protocol. It's that and a specific token is being whitelisted, someone deposit a token, someone borrow a token, someone withdraw, and someone repaid. Then we have our event for liquidations, and here is the meat of our platform. We allow deposits, and of course we basically get the address of the token that will be deposited and its amount. We add our modifier to verify that this token has been whitelisted, and we also have this modifier to signal that the amount sent should be greater than 0. Then the event is triggered and we just change the state accordingly, and we perform the transfer from the account that called this function, the message sender, to transfer to the address of this contract that amount. If it's not successful, then it will revert with this error. Something that I want to highlight here is that several of the functions, specifically deposit, repayment, and liquidation, require this transfer from, which in turn requires the owner of that token to approve this contract to transfer tokens in that specific ERC20 token on its behalf. This function is dependent on this message sender providing an approval for that specific amount in the token contract. Then we have the withdrawal, which is basically similar to the deposit, just totally the opposite. And we have the pool funds. The pool funds will take funds from a specific account and will transfer them to the message sender. And this pool funds is going to be used in several instances. Let's go to the borrow function here, and here we have that we require that the token that is being borrowed has a balance that allows for the borrowing of that amount, and then we increase the amount borrowed by the caller of this function. Then we emit the event, and then we transfer from the contract to the sender. This one actually requires that the health factor of the sender after all of these state changes have been executed is greater or equal than the minimum health factor, which is 1. This is to ensure that the borrower has enough collateral to fulfill its obligations. So we have it there. And the liquidations we are going to do as the last function, so we leave it for now. Repay internal basically is the same. You have to diminish the borrow amounts of the account that is being sent as a parameter here. And then there is a transfer from the message sender to the contract for the amount. The reason we are sending account here as a parameter, but we're taking the funds from the message sender, is because the liquidations are actually a repayment. So we have this repay, which is assuming that the message sender and the account are the same. So that's the reason that here we are calling the repay with the message sender as a parameter, as you can see here. But also in the liquidations, we are actually calling also repay, but with the account that we are liquidating as that parameter. So they both are using this repay internal function here. Now, all of this depends on certain information that we need to have regarding the account that is being liquidated. And for that, we need to get the account information, which is getting the total value in dollars of the tokens that that account has borrowed. And this should be in dollars. So I will just take it here and change it here. And then we get the value in USD of the collateral value and the borrow value. And for that, we have these functions, where what we are doing is just getting the amount of tokens in each of the allowed tokens, and we get their USD value. So we do the same for the collateral and also for the borrow values. This is just iterating through all the allowed tokens in the allowed token array. For getting the USD value, what we are doing is getting the price from the token to price feed mapping that we have declared above. Remember that we have to register a price feed for each of the allowed tokens, and that will give us the contract that we are calling to get the price. This is just mocked, and in a real scenario, that will be to store the address of a Chainlink price feed. So when we get that price, which since it is in US dollars, is 1 times 10 to the 8, because it has 10 decimals, we are going to get it here, and then we are going to multiply that times the amount of tokens, and we are going to divide by 1 to the 18 because the amount of tokens has 18 decimals. So this notation of the 18 decimals here and here will cancel each other, and we will just get the amount of US value with only the 8 decimals that the price has. So that's for that. And when we have that, we can calculate the health factor. So as you remember, the health factor is just the collateral divided by the borrow amounts, but we need in that case to adjust that collateral for the threshold of liquidations, which we are doing here. Since that is a percentage, we multiply for that number, but then we divide by 100, and that will give us the health factor. Then we have these functions here that are just modifiers, and this is the function to whitelist tokens. Now let's move to the liquidations, because this is the interesting part. So what is happening is that the liquidation function requires us to provide an account, what is the token that the liquidator wants to repay, and what is the token that the liquidator wants to get as a reward. Then what is happening here is that we verify that the account actually has a health factor that is less than 1, because if it's greater than that, it cannot be liquidated. And then we just move forward to proceed with the liquidation. And the way that liquidations are happening in this protocol is basically the liquidator will pay half of the debt in the repay token of that specific account. So here we're getting the repay token debt that the account that is being liquidated has. We divide it by 2. Then we get that value in USD, and that's the amount that the liquidator needs to pay. And it will be repaid in this statement here with the internal repay function. Now we need to calculate the rewards of the liquidator, right? So for the rewards, we need to get the reward value in USD. So we multiply the amount of debt in USD times the liquidation reward, and that's a percentage. So we divide it by 100, and then we need to calculate how much is that in the reward token. This is an opposite calculation to the one that we did here. Here we had the amount of tokens and we needed to calculate value of dollars. Here we have value of dollars, but we want to get the amount of tokens. So we get value from USD, which is another function that we have here. Very similar to get USD value, but just doing the opposite. Here we divide by the price instead of multiply by the price. And here what is happening is that we are going to get the total value in tokens of the reward token of this value in USD. Then that is going to be pulled from the collateral of the account that is being liquidated, and it will be given to the liquidator. Of course, an event is sent. And that's the way liquidations work. Now we're going to jump into building your own sandbox to play with DeFi concepts. We're going to build a very nice UI with Moralis, and we're going to deploy all of these contracts to set an environment to see this type of liquidations in action. Follow me through it. As mentioned, we have a little sandbox that you can use to familiarize yourself with these concepts that we have been discussing. This is built with Moralis. It has everything that you need out of the box. You can study the Moralis documentation to study what we are doing here in all of these functions that just execute the DeFi functions of our contract through the UI, and they rely in the functionality of Moralis execute function of our SDK. These are basically all that you need. I will not go one by one through them because this is focused only on the liquidations, and this little UI is just a way for you to practice the concept and understand it better, and you can basically reverse engineer it with Moralis very easily. But what you need from the blockchain perspective is these different addresses. You will need 2 tokens that you will be working on, and you will need 2 mock oracles, 1 per each token, and you will need the lending platform. And this lending platform will have to live here as a comment so we can use it, and also here because this one is the core of everything that we're doing right now. We need to set our development environment in a certain way for this to work. So we are going to start by that. We need to deploy these contracts and set them up, and I'm going to do it in Remix because that's easier. I don't want to give a full description of how to do it in Hardhat because that will deviate from the purpose of the video as well. There are a lot of videos that we have put together where we discuss how to do deployments in Hardhat or other platforms. Now we are here in Remix. I already copied all the contents of our Solidity folder of our repo here, and we're going to start by deploying the tokens. So we're going to do this one. We're going to go to injected web 3, which we have here. I will use my main account to deploy this. So here we are, and then that's it. Let's deploy it. It will require to have a token name, and we're going to call it token 1, and the symbol also token 1, and we're going to deploy it right now. The transaction was confirmed, so we have our first token. We're going to copy that one to our slot here just to keep it in our memory. Now we're going to deploy the other token that we're going to need. We're going to call it token 2, and it's going to be the same here. We just push, we send the transaction. That one went a lot faster. So we have our token 2. And now we need to deploy 2 oracles. For that, we need to compile them first, of course. So we have to go back to our files here, and we go to the mock oracle file, and we're going to deploy 2 of them. So we return here. We want to deploy the mock oracle, and that one requires an initial price. And we're going to have those tokens that we just deployed to be both worth $1 exactly when we start. So we're going to have 1 followed by 8 zeros to follow the Chainlink standard. 1, 2, 3, 4, 5, 6, 7, 8. We deploy this one. Let's hope that the transaction goes fast. That was quite fast, so we just copy that one, and we have Oracle 1. We will need Oracle 2. We return to Remix, and we are going to deploy it exactly with the same price. And that's it. We have the second oracle. Now we are going to deploy our lending platform. We're going to go back here. We open the lending, save, then we go back here and we want to deploy lending, which is this one. That one doesn't require any parameter to deploy, so we just deploy it. And we have it. Now we have two oracles and our lending platform, and we will put our lending platform here. We need to have a liquidator and someone that is going to get liquidated. So that means that we need two accounts to be actually interacting with this, and those two accounts have to have our tokens. But since I deploy these tokens with my main account, that's the only one that has tokens, so we need to transfer some tokens to the secondary account. So I have my secondary account here. I will copy it, and then I will transfer from the first ERC20 that we have here. We are going to transfer 100. So I want to transfer to my secondary account 100 plus 18 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's because I deployed the wrong contract. So we have still the oracles that everything works, but what we should have deployed is not ERC20 but token. So that's it. The same thing, we're going to call them the same. Okay, we have the token. So this is actually the token. Then let's go to deploy another one. And here we are. We have it, we're going to copy it. And now we can do the transfer, which is what we wanted to do before. So we're going to go here and to transfer to my secondary account, which is not this. This is the token itself. We need to have my secondary account, which is this one. And then here we're going to send 100, 17, 18. Transact. Now it's working. And then we need to transfer also TK2. So it's the same. Transfer 100, 17, 18. And we transfer that to the secondary account. Now we're set, but we are still in need of doing something else. We need to whitelist our tokens in the lending platform. So this is not working. Well, let's redeploy the lending platform. Here we are. This is correct. Now we need to whitelist our tokens. So for that, we need to set allow token, and this is going to ask us for the address of the token and the address of the price feed, which is easy right now. And we're going to first copy the address of our lending platform before we forget. So we have the lending platform here and here. And we are going to get token 1. It's going to have its price feed in Oracle 1. And we send it. While the transaction comes, we're going to set the information for token 2. We are going to copy token 2. He's going to have his price feed in the Oracle 2. If you notice, the link between the token and its price feed is on the lending platform. The transaction already came, so we are done. We set our development environment. Now we're going to go back to our UI and execute a little bit of a liquidation there based on this environment that we just set. With our environment properly set, we can start exploring with our little dashboard here how this works. We're signing in, and here after I sign in, then I'm populating what is my status in the lending platform. Remember that all of this information, we have it here, and we just populated that lending platform that we deployed here, and we have all that we need here. We have a login function to trigger immediately after we load the page, which is around here, and we have our Moralis start just before that, and then the login function will basically get the current user in the lending platform. So that's what we have here. We then get the collateral value, the debt value, and the health factor of this current user. We are going to deposit with this user right now an amount of token 1 of 100. So we're going to put it here, and we're going to deposit 100. First, what is going to happen is an approval, because remember that this needs to be approved before the lending platform is able to take the funds from the user. So this will take a while. This primary account is going to be our liquidator actually later on. So we got this message, approval granted, and then we proceed to deposit, and the deposit is made, and right now we have $100 as the price of our collateral, and the debt value is 0 and the health factor is 0. Now we are going to have our secondary account deposit the secondary token as collateral, but for that we have to make sure that the secondary token price is actually the same as the primary token. We are going to go to this Oracle, and we are going to verify what is the current price. Go back to Remix, and then we are going to get the mock Oracle. We have it here. Here it is. We are going to get it at this address. Yeah, that's Oracle 2. Let's get it. Now we have the Oracle here. We check the price, and we check that the price is actually 1, followed by 1, 2, 3, 4. And 134, A0. So this one is equal to $1. Now we're going to return to our dashboard, and we're going to switch accounts, and we are going to go to this account here, and we're going to refresh. We could have added an action there to refresh immediately on account change. Moralis allows to do that very easily, but we have it here. So we have the secondary account here. That one has nothing there. We're going to deposit the token 2 as the collateral of 100. So we're going to get the approval message first. We have 100 for approval. We approve them. After this one is approved, then the deposit is going to take place. And here is the deposit coming, and the deposit will take place in a while. So we have it here, no debt, and the health factor is 100 still. Now let's say that this person wanted to borrow, and we're going to borrow the maximum that it's going to be able to borrow right now, which is 80%. So we are going to borrow 80, but we're going to borrow that in the other token 1, which has liquidity because our primary account actually deposited that one. So we're going to borrow 80. We wait. So right now the borrow operation is here, and we have borrowed all the tokens that we were able to borrow. But this is very risky for this user, because a very minimum change of price would actually trigger a liquidation for him, which we have seen very often lately in DeFi. But for this, we need to go back to our primary account, which is going to be the liquidator, and we're going to change the price of the Oracle. Remember that there are ways to manipulate centralized Oracle services through attacks. But if you have a decentralized Oracle solution, then this manipulation is more unlikely. So we go right now to the Oracle, and we're going to change the price. Instead of being $1, we're going to change it to be 99 cents. So 1, 2, 3. We're assuming that this price is honest, and that's it. The price has been updated. Now, if we go to query what is the status of this account, and we can do that with liquidate here, we can see the value of the collateral of the other person already falling by this amount. Now we are going to proceed to liquidate. And for liquidating, we need to put the repayment token and the reward token. So the repayment token is going to be the token 1. And the reward token should be the token that the other person had in its collateral, which is going to be token 2. Of course, in a real scenario, there is a lot of research or a certain amount of research that have to happen to discover these parameters for the liquidators. Now we are going to liquidate. First, we're going to have an approval here. And this is for half of the debt, which is 40. And here we go. The approval was granted, and then we're going to proceed to liquidate the account. Liquidation complete. Now we're going to query again the status, and the collateral is 57, the debt is only 40, and the health factor was returned to 1. So the platform is solvent again, it's properly funded, and the liquidator got a reward in that latest transaction. So we're going to check the token 2 holdings right now. We have 57.57 staying in the contract, and then we have the rest that was like 42.42. That was the amount of tokens that was paid to the liquidator. But if you remember, he paid a value of $40, half of the debt of the account that was liquidated, and he's getting a little bit more than that in the reward tokens. That's the way liquidations work. Thank you very much, guys. I hope that you have enjoyed the video, that it has been instructive. I didn't give you a full walkthrough of the UI because that was not the purpose, but you can just interact, review there, and with the Moralis documentation, you are going to be golden to know how this dashboard works. This is Daniel. Thank you. Until the next video.